I'm excited to hand things over to Shirish. Thank you. Take it away.
Right. Thanks, Katie, and hello, everyone. My name is Shirish More, and I'm the AI Program Product Manager within the Siemens Digital Industry Software. And in this role, I work across all the product segments to define and drive a unified AI strategy. And what you will see today is how this strategy is driving AI capabilities inside of NX and Teamcenter. And then in this role, I'll drive the strategy across the broader Siemens portfolio as well. So the plan is to walk you through how AI is transforming NX and Teamcenter as a connected, intelligent ecosystem, supporting designers and engineers throughout the product development processes. We'll look at how AI-driven copilots, both in NX and Teamcenter, will help you realize efficiencies going forward, as well as we got some nice predictive AI capabilities, which are nothing but machine learning models that are deployed on the user's machine, right? So you will see a flavor of Copilot, where we are heading with Copilots, that will have predictive AI in NX, helping streamlining your design processes, accelerating the decision making, improving data quality as you start developing or working on your product. So my goal today is to give you a clear understanding of what's possible today with the released products, as well as at a high level, where we are heading as we continue to build the industrial grade AI inside of NX and Teamcenter. So before we dive into what Siemens is doing with AI, it's important to understand the scale and speed of this transformation, right? Means generative AI, as you can see from this slide, is the fastest adopted technology in human history, right? Even faster than the internet and personal computers that we all know about, right? So what previously took about 8 to 10 years for technologies to evolve, generative AI has achieved it less than 2 years, right? And this rapid shift is signaling to our customers, right? In this case, to you who all are attending the session, that the engineering teams and application engineers are already expecting such kind of AI to drive their workflows, to help them with their automation, and Copilot is going to be a natural part of your daily tools, of your engineering tools that you use every day, right? So for us in NX and Teamcenter, what this means is that AI is not just becoming an add-on, or it's not just something that you're aware. It's going to become a core capability that's going to speed up productivity. It's going to start helping designers and engineers to make decisions faster. And humans will always be in loop. You will see today from my presentation as to how we are, still keeping the humans in the loop, because in the end, humans will be the decision makers. And Siemens is uniquely positioned to lead, because we are grounding the AI technology in engineering context, right? And context is going to play a very key role for those who might have already tried ChatGPT, DeepSeek, or Anthropic models. They traditionally are trained on knowledge that's general knowledge outside of the core engineering knowledge. But the reason we are, when I say we, Siemens is uniquely positioned, because we can now ground the technology that we deliver in context of the engineering language, right? We can speak the same language that engineers and designers speak, and we have that domain knowledge, and we can help the customers also leverage their knowledge and drive the AI components going forward, right? So we are uniquely positioned as to how we can bring this generative AI technology as part of the engineering solutions that you are using. So when we talk about AI at Siemens, we are not only talking about generic consumer AI or experimental prototypes here and there, right? Our focus is on industrial grade AI. What it really means is that AI that meets the strict requirements of engineering workflows, right? Means yes, there is statistically predictive thing going on, but how can we make it more descriptive, right? And how can we make it such that AI can be used in regulated environments? It can be used inside of your enterprise, right? So what makes Siemens different is that we understand the product data, right? And we understand the engineering context and the domain constraints that consumer AI models do not capture. But whereas, in case of Siemens, our goal then becomes to help customers build truly sustainable digital enterprise where AI is grounded in the historical data that was approved and released. The AI is grounded in reliability, security, trust, traceability, and industrial value. And what does mean is what it means is that the industrial grade AI then enables customer to trust and scale AI across their entire product life cycle. So the power of generative AI has shown, means we all know the power, right? Means it's learning things from the public data domains, things like text, images, audio, video, code. We use our smartphones day in, day out to search things. And basically what's really happening behind the scenes is that the AI models that are there getting used in public data domains is using the language of internet, right? So that's what most consumer tools are built on. They perform extremely well, but they are trained on open, unstructured data. But when you look at on the right-hand side, the engineering and manufacturing areas, we speak very different languages, right? Means our data, our modalities come in form of complex CAD geometry. We can have product structures, product metadata in form of assemblies and simulation results, system diagrams, and schematics, bill of materials. These are your proprietary data, and you have the knowledge, right? So we are building a system wherein when you start incorporating AI techniques, you can retain your IP within your premises, but we will have tools that learn, and then you can deploy those models within your premises so that it can just speed up the overall product development process, right? And this is where the generic models will fall short, because as I explained, the generic ones out there are they understand the language of internet. They just simply don't understand engineering intent, constraint, tolerances, for example. And this is exactly where Siemens is going to bring unique value through domain-specific models, physics-based models, physics-informed data. We can understand the language of engineers. Behind the scenes, we are looking at the engineering ontologies, and then we have a deep integration with the engineering tools that are used throughout the product life cycle, right? And that's the beauty of working with Siemens and partners like Saratech, is because now you will start realizing AI applications which are AI in applications, right? And this is what allows us to turn the generative AI into real productivity accelerators for engineers going forward. So what we are trying to do here is Siemens is building a true lifecycle intelligence by connecting 4 powerful AI capabilities into a single ecosystem, right? It starts with the industrial foundational model, which captures the intent, which captures the physics behind the products. It captures the domain knowledge. And then on top of that, we are going to embed the in-application AI, and you will see from my demos how and why it's very important, right? And then, and it can be in application AI instead of NX, it can be instead of Teamcenter, and then we then extend it into digital thread agents, right? Wherein now these agents can not only understand the language for that particular domain or application, but it can automate multi-step workflows across different applications, not by just answering questions, but actually performing tasks. And I'll give you a couple of examples wherein you will see that when the user is asking for some suggestion or help in sort of Copilot, how behind the scenes the agent can also invoke the commands, prepare data for the user. And all of this is enabled by the data fabric and machine learning models, allowing us to bring together informations from multiple systems and with the industrial grade security that, as I mentioned, with traceability and governance around all of the models that we deploy with the application. And when you combine these 4 layers, you unlock an intelligent reasoning application, end-to-end engineering environment where data, machine learning models, and AI agents work together across the full product life cycle. And that's the beauty of having AI directly inside of your application. So let's jump into Designcenter NX and see AI in action. So Designcenter NX has been steadily advancing engineering intelligence over multiple releases now. We were in fact the first CAD product in the industry to introduce something called adaptive UI or AI-powered capability long even before Gen AI or generative AI became the mainstream, right? And that early innovation was recognized. You can see that we received a number of awards, and since then we have expanded those predictive AI capabilities in every single release, adding features like selection prediction, region recognition. We got some nice Discovery Center recommendations going on based on how other users in community are using AI and or NX applications, and all are designed to help users realize efficiencies, throughout their product design lifecycle. We help users automate repetitive steps and make expert workflows more accessible now inside of NX. And now, the rightmost column there, with the introduction of generative AI, we are now entering the next phase, wherein we are bringing Copilot inside of Designcenter X NX, as well as we are introducing workflow guidance, wherein the Copilot and agents can suggest things as the designers are working in NX. And this evolution reflects the commitment from Siemens to continuously enhance the engineering solutions by enhancing or helping engineers realize the productivity gains with trustworthy and industrial grade AI going forward. So let's jump into Copilot. Copilot is our engineering-focused generative AI that brings some expert-level guidance directly inside of the NX application, right? It interprets the user intent. It can translate the prompts into domain-specific commands, and you will see both in NX and in Teamcenter how the user don't have to, go and search for commands. The user can just say, well, I am working on this design, can you help me optimize it? And it understands the intent and then generates some nice list of things that user should perform, right? So there are some nice things going on here. Behind the scenes, we are leveraging a specialized model that was trained to understand the engineering language, as well as translate those prompts into APIs, which can then execute the commands, right? So in the end, the result is much faster execution of a complex task, reducing onboarding time. And number of these videos, I myself, I have authored this video to show you how I have never worked on certain areas in NX, and well, I'm getting some help from Copilot, and it really helps reduce the onboarding time, improves the accessibility to the knowledge that the Copilot has learned from technical documentation, from industry specific best practices, from some historical data, right? And that's the power of having the Copilot inside of NX, right? So here is a quick demo. You can see how I'm working against this automotive early concept design, wherein my task is to optimize the luggage volume, right? And on the right hand side, I have my Copilot, up and running, and I'll play the video. So you can clearly see I got some concept surfacing that I got from the studio department, and then I'm trying to optimize my geometry here. So you can see I'm saying, oh, I need help optimizing the volume using Design Space Explorer, right? So clearly the Copilot says, all right, I can see what you are working with. Here are certain steps, and what you will notice that as the Copilot is giving suggestions to the user, I can directly ask the Copilot to invoke the command as well. It looks at the configuration that I have going on, suggests certain things, and it came back with some nice sequence that says, oh, you need to follow all these steps if you decide to optimize the luggage volume here based on the design variables, objectives, and constraints, right? And you can clearly see, at least with the release that I'm showing here, it's allowing the user to click on the commands that the Copilot is recommending. But in future, based on where we are heading, you can clearly see that I can look up a historical data set or some best practices, and I can even start suggesting the range. If this would have been a sedan versus an SUV, I can look up the requirements or standards and start suggesting those parameters directly. And now the user says, I'm satisfied with your steps that you recommended. Please go ahead and run the optimization for me. And it came back with the results. And the Copilot is saying that once the run is complete, launch the results, go through all different solutions that I tried to converge to. And then the green one there is the one really what I think you should go with. And then the user clicks on it, and you can see that the volume has been optimized based on all the different design variables, constraints, and objective that the user asked the Copilot to use, right? So that was a quick demo just to give you a glimpse into how we see Copilot going forward, helping designers. And just to give you some insight into the architectural components, we basically trained the large language model here using some of the historical data as well as some of the application specific best practices. We also trained a small language model that understands the responses and allows the user to directly invoke the command. Means you saw in the demo there how I was able to just click on what the Copilot was suggesting. And in future, I can say, well, Copilot, just go ahead and do it for me, and we can still run through the same steps and execute those commands in a form of an agentic AI architecture. But you see where we are heading from a Copilot perspective. The next thing I would like to demo here, or at least give you an idea that in NX, I don't know how many of you are aware that we got this Designcenter AI or Discovery Center, which provides some nice personalized context-aware recommendation. The way it works is that it learns from the user behavior, and it matches the user's behavior to how other users in the community are using NX. And based on a pattern matching, it starts suggesting some nice things inside of the Discovery Center. And in here, in this image, you can see how the AI detected the pattern that the user is working on an injection molded part. And I'm going to start giving some recommendations and tips and techniques as the user works on his design, right? So it learns from the user behavior. It matches those behavior with the usage pattern across the globe, tries to find similar users and then brings back some tips and techniques inside of the Discovery Center to guide users towards the most relevant tools, workflows, and best practices, right? So clearly you can see where we are heading, with this approach, wherein it's generating new content, generating some recommendations based on the context in which the user needs help, and in this case, it reduces the training needs, speeds up the task execution, minimizes the trial and error, helps both the new and experienced users to become more productive in a much faster way. Next thing I would like to highlight is a predictive AI capability, wherein command prediction uses AI to anticipate the next step a user is most is likely to take or use based on the user's history and the successful past patterns that the user might have used, right? So it prioritizes the most relevant commands and detects a repetitive behavior to streamline workflows. This reduces clicks, accelerates design tasks, and helps prevent errors by guiding users towards the most optimal action or command that he should use throughout that workflow. And you will see here a quick demo wherein, and this is a real world scenario wherein I tried to create a tooling for this drone cover, and I have never used Mold Wizard. And you can see throughout the demo, I'm not even in the Mold Wizard application, right? So I just click on the third mouse button. That's how I have configured my AI engine. So wherever my mouse is, it shows me the next command or sequence of commands that I should use, right? So clearly, when the user says, I need help, it shows exactly which command to use based on the previous set of commands that the user might have used. And it uses some nice advanced predictive AI capabilities. It uses Markov chain for those who are familiar with some of the techniques that AI uses. But in this case, you can see that maybe the user has used he might have used Mold Wizard previously, but then it learns from what he might have used it for, and it detects a pattern. And in this case, it gets into a situation or position wherein it can predict exactly which command the user might end up using. And it's very, very powerful because, as I said, throughout the demo video, I hardly went into more wizard application, or I might have a cheat sheet lying on somewhere as to how to use the command, but it has learned from all previous actions, and it reaches to a point where it can predict exactly which command the user might use in this particular context, which is nothing but creating a tooling for this particular drone cover, right? So that's the beauty of using AI in context, and then suggesting things to the user while the user is working. So that was a quick demo to show how not only the previous two ones were generative AI, but I'm just giving you some insight into how we are using predictive AI as well. Yet another powerful predictive AI capability is selection prediction. A number of times designers end up picking things around. So what we did with selection prediction is that we are using AI to anticipate which geometry the user intends to select next. It previews the predicted objects using it gives a preview to the user, and then allows the user to select those predicted objects, and then you can then perform any operation on those selected objects, right? So this dramatically reduces the manual clicking, searching for things, zoom in, zoom out, and a lot of other things, because AI can start predicting based on the command that you are using what you might select, right? So here is a quick demo wherein the user is trying to create an edge blend for this particular aero component, right? And he selects the inside profile. The AI predicts that, well, if you're going to apply blend for that profile, I'm going to suggest or predict that you need a blend for other similar profiles. And the user says, oh, I like what you are predicting. And in 2 clicks, the AI was able to predict the similar profiles. And while the user is still in the same command, he says, all right, I'm going to apply the blend for the outside edge, right? And now you can see the AI is predicting that, oh, what about the other edges? Do you want me to apply blend or select those entities for you as well? And I bet you this action would have taken a number of clicks, zoom in, zoom out. On top of it, you would have missed one of the edges, and then downstream, somebody finds that issue, right? But in that demo, you saw how I just used two clicks and I was able to predict and select all those entities. Here is another example wherein the user is trying to apply the chamfer on those mounting holes, but the AI predicts that, well, if you're going to apply chamfer, all those other mounting holes are similar diameter, are normal to that face, the top face. I'm going to just help you apply the chamfer to those all mounting holes. So these are some of the nice examples wherein you can see day in, day out, number of users are using command prediction, selection prediction, and whatnot. And now it's like AI is embedded seamlessly, wherein it can apply, help speed up a lot of things for user. All right, moving on. Very similar to command prediction and selection prediction, we also have something called select similar components, wherein there are a number of use cases wherein and I'm just going to do a demo with a very large assembly wherein designers would like to narrow down their selection. They would like to, parse through different components, declutter the complex assembly into a manageable set of components. And majority of the times, the user has to go in the assembly navigator, expand the components, select those individually, or they will do some manual selection. But where the AI really comes in handy is when the user is loading the data set. What we do is we apply some nice AI algorithms, and we recognize all the shape of the components, geometrically similar components, and then we store it in the memory, so that when the next time when the user says, oh, can you select similar components, use this as a seed component, we can automatically select all those components for the user. So here is an example wherein the user is working against 17,000 plus components, and he really would like to calculate the weight of all the similar components that are on top of the board there, right? So you can see he invokes the select similar components. We are processing all of this data. You don't need any additional infrastructure. It's all happening in the memory. So we apply some nice AI techniques, and when the user selects one of those seed components as for selection or for finding similar components, you can see how AI is predicting that, well, I'm going to use the, that particular component and select all similar shaped components that matches that criteria, right? So in one click, you can see how he was able to bring all those components, and then once those components are selected, he can deselect, select additional components, and then apply any operation. In NX, you can apply then operations, like in this case, the user says, well, calculate the weight for all those similar components. So you can see how easy it is for users to use techniques like these going forward to simplify selection, performing operations, both for the selection prediction as well as, in this case, selecting similar components. And I'll move on, but it just demos a lot of other things wherein now the user is interested in horizontal or components that are oriented and but still similarly shaped and whatnot. Okay, and then finally, one more thing on the NX side, very similar to the select similar components, we have something called select similar faces, which uses AI to instantly recognize and group similar regions across piece parts, across assemblies. It lets user locate, validate. You can perform operations on similar faces in real time and even build some custom rules or custom libraries wherein, for example, on this slide, and I'll show you a demo. If you are a user who is normally interested in beads on a sheet metal part, you can then store those set of faces as beads, call it whatever you want, and then AI learns from those faces. And next time when you're working with similar design, you can say, AI, go and find all beads because I want to perform an operation. I want to calculate surface areas, or you want to perform synchronous technology and move those regions by 1 millimeter. So there are a number of applications wherein users tend to work on similar faces, and you will see from this demo wherein I'm working against this floor assembly for an automotive sub-assembly, right? And I'm interested in applying, performing an operation on those beads. So traditionally, the designer would have gone in and manually selected individual beads, and then, there is a lot of zoom in, zoom out, and whatnot. But with AI, what I'm going to do is I'm going to say that, okay, select similar faces. I'm interested in such type of a region. So it collects all those faces, and then I can say perform search, and it's going to go in and perform search and find all similar regions that now once selected, you can say, oh, I like all the regions that you found, but I'm interested in maybe in a couple of those regions, maybe in this case, the middle ones, and AI, go and find only the regions that I'm interested in. So you can see how advanced AI algorithms we are using here to help designers speed up the overall selections, and then once selected, you can perform any operations against those regions. All right, so that was a quick run through. As I said, just to summarize, I covered just few of key AI capabilities inside NX, but there are many more built into the product. I just wanted to give you a glimpse into how we are leveraging generative AI, predictive AI. These are all features that run inside of your NX application. And for anyone on the call who is interested in exploring further, the NX documentation provides detailed guidance, examples, and full listing of all the AI-driven features that are available today and how you can take advantage of those features. Now, let's shift from NX to Teamcenter and look at how we are bringing AI directly into core PLM workflows. Just like Designcenter NX, our focus in Teamcenter is on in-application AI, right? That AI that's embedded inside of Teamcenter tool, which users can rely on every day. And these capabilities that I'll demo will show you, or you will see how it's going to help users navigate some complex data structures, automate some routine tasks, and surface insights that normally will take time to find, right? So the first thing I would like to demo or talk about is Teamcenter Copilot. Very similar to NX Copilot, Teamcenter Copilot is going to bring truly context-aware AI inside of the PLM workflows. You can clearly see that the Copilot understands the context in which the user needs help. It can be the document, the bill of material, that's displayed on the screen, or he might load an assembly in the embedded 3D viewer and then perform operations, right? So clearly Copilot can instantly summarize things for the users, extract contents, and because there is a bi-directional interaction going on between the Copilot and the context in which the user needs help, it's much easier for user to trace back to the original Teamcenter source, giving customers confidence and traceability, right? So here is a quick demo wherein I'm in Teamcenter. I got this Chevy Bolt loaded in my session, but I also have a requirements document associated to that particular vehicle program, right? So in this case, I said that, oh, Copilot, I got these requirements. I'm interested in, finding some requirements. Can you parse through this entire document and summarize some nice, some requirements that I should be aware of? So you can clearly see, traditionally, the user would have gone in, or he might have created requirements objects in Teamcenter and, other things, but I'll talk about that as well. But clearly, you can see the advantage of having a Copilot embedded inside of Teamcenter, wherein I can just say stand on that particular requirements document, make that as your context, and help me understand the requirements. And you can see the user just goes in and he prompts the Copilot to go through different requirements, narrow down the focus to a particular area. That's perfectly fine. Then he changes the context. You can say, Copilot, now that I understood the requirements, can you help me, do things against the bill of material that's that's active now, right? So you can see how the user says that, yes, can you locate the radar component and all other things that are associated with that particular radar. Not only the Copilot comes back and gives the responses, but it also, shows additional things and highlights the component in the active view. So that's the power of having AI Copilot directly embedded in Teamcenter for helping out things like bill of material searching, summarizing the requirements document, and other things. Moving on, very similar to the previous demo here, as a user, I have this particular truck assembly loaded. Traditionally, you would have gone in and applied some compound search, or compound filtering. But now with Copilot, I can just say, please filter down to parts in chassis zone owned by so-and-so person or owned by a particular group. You don't have to go and apply those compound filtering using the traditional search, but the Copilot now translates that prompt, executes command, comes back with a list of things that the user might be interested in, right? So another application where it perfectly understands the user prompts, translate that into an actionable command, and behind the scenes the agent is executing those command and understands the context, and there are a lot of things going on here that you can see, wherein now the user says, all right, for that particular structure, can you do further filtering, and the Copilot can basically help the user out. And finally, a powerful use case of Teamcenter requirements, wherein what's really happening on this particular use case here is that it brings multi-agent AI into one of the most detailed heavy parts in managing requirements. It can automatically import, classify, learn from those parameters, and then because it's a multi-agent AI going on, each AI agent can handle a specific task, working together to streamline what is typically a very manual and time-consuming process. And the result in the end is faster requirements processing, higher quality, and because AI is also monitoring things that are there in the requirements document, it can start suggesting things back to the user. All right, and finally, I think AI, now that you have seen where we are heading, what's going to happen is customers who are listening in, AI adoption isn't just a technology shift, right? It's going to be a transformation in how engineering work gets done. Many of you are already excited about AI, but they often ask me questions, and I know there will be questions after my session here. Where do we start, and how can we build confidence and realize value quickly, right? And we are here to guide you through this journey, right? This framework that we are developing will help customers introduce AI responsibly and scale it effectively, and you can unlock measurable impact across your engineering workflows and product lifecycle workflows. And the slide that I'm going to show you is normally that I present to the customer is how you can take a simple, practical approach to adopt AI in more controlled and measurable way. Most of the teams that I talk to, they start at the crawl phase, wherein they can say, okay, let's start with individual productivity, start using predictive AI and out-of-box Copilot. These are low-risk use cases wherein it's not touching the geometry, the human is still in the loop, and then you can say, all right, now that you are all confident in using the crawl phase, we can now jump to a walk phase by using AI to assist decision making. And then as your organization matures, you can then move on to run stage. And then finally, the fly stage is where now customers can unlock full efficiency by tapping into your historical data, your best practices, and AI agents are automating things and speeding up things for the user, right? So this kind of model helps customers scale AI responsibly and ensures measurable values at every AI step or AI journey that you will be taking going forward. All right, so with that, I think I'm going to hand it over to Katie again, and I'll see if there are, I didn't pay attention in the chat if there are any questions.
Awesome. Thank you so much for walking us through all that. We do have a couple of questions. The first one is, how does Designcenter Copilot interpret design intent when suggesting geometry changes or features?
All right, so for the release that's already out there, as I explained, right now we have trained the large language model just to go based on the prompt. It's not looking at the design, and we are not uploading any images of the design, but you can always translate your design in a form of a prompt, and then it will understand it. So I don't know whether you noticed it, but when I was showing you the optimization scenario, I did explicitly mention it to the Copilot that I need help with design optimization task, right? But in future, we do have the ability to look at the image and reason out of that image as to what the user is trying to do. And for that, we are closely working with customers, because there are customers who would like to know, are you capturing the image of the screen and sending it to the cloud? And there are certain things that we are considering, but we do have the ability to do it. And that's the reason why I said that, in my crawl, walk, and run and fly, let's start with simple prompts, documentation, and then in future, as the architecture evolves, you can then decide, oh yeah, gather on the fly, understand the context in which user might have all those questions, and we can easily do that. Okay, I hope that helps from a roadmap perspective as to where we are heading.
Awesome. How about how is AI improving search accuracy in large Teamcenter data sets?
So the search, I think what happens is, and you saw in my demo, when the user said that, well, I'm interested in the chassis, or I'm interested in a fuel pump, we extract those components, we bounce it against the traditional indexing that might have happened. So from an accuracy perspective, it's pretty accurate, because we do pick on certain component names and then use those names, enrich that with the rest of the sentence or the prompt, and then bounce it against the large language model. So in our testing and validation, it's pretty accurate, because there is a dual task going on. It's not just large language model, it's the indexing data that we use and leverage the traditional search. On top of it, we understand the natural language in which the user is asking the question. So the approach that we have taken for search in Teamcenter should be pretty accurate going forward when you execute that search directly from Copilot. Okay.
Awesome. And then one last question. Which Designcenter NX workflows see the biggest performance gain from AI assistance, such as generative design or feature automation?
Yeah, generative AI is the biggest one. And then, as you noticed, there are certain predictive AI ones, like the selection ones are pretty awesome. And then once we start automating the tasks, like not only give the suggestions to the user, but the user might say, for example, the Copilot might come back saying that, Mr. Designer, you have not assigned the material for this particular design. So and so material do you want me to assign? When the designer says yes, we are in a position to go ahead and assign that material to that particular solid body, right? So and that those are some of the agentic things that you will see will really speed up the overall process. Human is still in the loop. It's just the automation aspect wherein you don't have to orient the design and release before release, go through all your checklist. You can just tell the Copilot, okay, go ahead. You know what I end up doing always before I save my design, perform those tasks, right? So you will see some serious efficiencies gains and usage around those kind of workflows, okay?
Awesome. Thank you so much. That's all the questions we have. Thank you guys all for joining us today. This session, along with many others, are also available on our YouTube channel at Saratech. So subscribe to discover more helpful and original content. And we also have some training courses available on our website as well, anything you might need. And if you have any additional questions or comments, you can include them in the survey right after the session or email us at marketing@saratech.com. We appreciate all of you being here. Thank you again, Shirish, for walking us through everything going on with AI with Siemens. I hope everybody has a great rest of your day.